angles that can be formed inside of circles or outside of circles by some of the special lines that we've talked about already. We have two theorems for today. Theorem 9.9 says an angle formed by two chords that intersect inside of a circle. So we'll get a picture for this one. We've got a circle. We've got two chords that intersect inside, and they form really four angles, but we'll just focus on one of those angles. It says the measure of that angle is equal to half the sum of the measures of the intercepted arcs. So that means the arcs that they cut off. So we'll call this arc X and this one over here Y. And according to Theorem 9.9, the measure of that angle is equal to 1/2. What's sum mean? Addition. Add up those two arcs. So we've talked about a couple of angles inside a circle so far. We talked about a central angle, which is an angle whose vertex is at the center. We talked about an inscribed angle, which is an angle whose vertex is on the edge of the circle. So if the vertex at the center, if we have a central angle, what was the measure of that in relationship to the arcs?
The measure of the central angle.
How big was the central angle?
The same.
The same as the measure of the arc it cuts off. What about an inscribed angle? That was our last lesson. Half of the arc that's cut off. And now this one is a vertex that's just kind of somewhere in the circle. It's not at the center. It's not on the edge of the circle. It's just in the circle somewhere. It says that it is going to be half of the sum of the two arcs that are cut off. In math, if I have two things and I add them up and then I divide by 2, what's another way of saying that? What word means half the sum of two things? The average of them. So what this theorem is really saying is that that angle is equal to the average of the two arcs that are cut off. Okay. The next theorem says if I have an angle that's formed by two secants, two tangents, or a secant and a tangent, one of each. So there's a few different ways we could draw our picture here. We could have secants. What are secants again? Remind me what a secant looks like. In terms of trig, we learned that it was the reciprocal of cosine. In terms of a circle, what does it look like?
It's a line that contains a chord extended beyond the edges of the circles.
A line that contains a chord and extends beyond the edge. So secants are like chords that just keep going. So the measure of an angle formed by two secants, so that's going to occur outside of the circle then. Or it says two tangents. What are tangents? A line that hits one point of a circle. So that would happen outside of the circle as well. Or it says we can mix and match and have one of each, a secant and a tangent. And I won't draw another picture of that. But in any of these cases, we're getting an angle formed outside of our circle. It says the measure of that angle is equal to half the difference of the measures of the intercepted arcs. So we'll label those arcs that they cut off. And this theorem says the measure of the angle is half the difference. What's difference mean? Subtraction. Now I wrote x minus y. Would it work to y minus x?
Yes.
No.
Why or why not? According to the way the pictures look. It would change my answer. What would it do to my answer if I did them backwards? it'd make a negative, and that'd be a problem. We don't want to consider negative angles. So when you're doing half the difference, always make sure that you're doing the bigger arc minus the smaller arc. Okay? So, two theorems. The first one, if we get an angle inside of the circle, and it's not a central, and it's not an inscribed, but it's inside of the circle, it is half the sum of the arcs. And our second theorem, if we get an angle outside of the circle, it's half the difference of the two arcs. Questions on those two theorems? Okay, let's look at some examples. All right, so I have 9 pictures up here for you. In the first 6, your job is to find out how big the angle is. The angle is labeled as number 1, 2, 3, 4, 5, 6. So in the top 6 pictures, we're looking for how big that angle is. In the bottom 3, we're looking for how big x is. And for those, you will need to set up an equation to solve. Question? Go ahead and take a few minutes to look at these and try some of them. I'm probably not going to give you enough time to do them all, but I want you to give some of them a shot on your own, and then we will talk about all of them together. 1, solving for angle 1, which rule would we apply there? The first theorem. Since it's inside, that theorem says that an angle formed by 2 chords is equal to half the sum of the 2 arcs. So add them up, multiply by a half, and that gives us that angle is 35. The other one would also be 35 because they're vertical angles. Right? Second one, that angle is outside. So our rule for outside was the second theorem that we looked at, which says that an angle outside is equal to half of the difference. And when we do that subtraction, we want to make sure we're doing bigger minus smaller so that we don't get a negative answer. So 120 minus 40 is 80. Half of that is 40. So that angle would be 40. It is a coincidence that that is the same as the closer arc. That is not a theorem. That does not work. It just happens to be in this one the closer arc, but we have to do half difference. Which rule would we apply in number 3? Half the sum or half the difference? Half the sum, since it's an inside one. So we do half of 135 plus 140, and that gives us 137 and a half. Number 4, half the sum or half the difference? Difference, since it's outside. Now this is kind of a problem because we're only given 1 arc and we need 2 arcs if we're going to do a difference. So what is the other arc, or how do we find it? It's 100. How do we find it? The full circle should be 360, so 360 minus the 260 gives us 100 for that inside arc. And then since it's an outside angle, our rule is 1/2 the difference of those 2 arcs. So half of 160 means that that angle is 80. Number 5, half the sum or half the difference? Difference, since it's outside. So the measure of angle 5 is equal to 1/2 of 170 minus 80. 170 minus 80 is 90. Half of that is 45. Number 6, half the sum or half the difference? Difference, since the angle's outside. Difference of what? Yeah, we need to not just use the numbers in the question. We need to use the 2 arcs that are in that angle. So we can use the 160, but we need to know how big that other arc is that's in the angle. How do I find that? 360 minus what we've used up so far, which leaves 80 left over for that inside arc. And then our rule would be that the measure of angle 6 would be half of 160 minus 80. You need to make sure you're using the two arcs that are in the angle, not just any two arcs given to you in the problem. So that gives us an angle of 40 there. For the last group of questions, we're going to be applying the same theorems, but we're not solving for the angle. That means we're going to need to set up an equation to solve. For the first one on the bottom, which rule would we apply? Half the sum or half the difference? Half the sum, but this time we know what the angle is. It's 75. So 75 is half the sum of 100 and x. How do I get rid of that 1/2 in the equation? Multiply both sides by 2. So that gives me 150 is equal to 100 plus x. And x would be 50. So if you are solving for an arc, not the angle, we'll apply the same rules, but we'll need to set up an equation to solve. For the bottom center, which rule are we going to apply? Half the sum or half the difference? Half the difference, and we know the angle, so 30 is half of. Now we're going to do a subtraction. Do we want to do x minus 70 or 70 minus x? X minus 70. In the picture, x is going to be bigger because it's the further away one. Whichever one is further away is going to be the bigger one. And we want to make sure we do our subtraction the correct way. You'll get a negative answer. So if you get a negative answer for an angle or an arc, you know you're wrong. So go ahead and try again by switching them. Like the last one, multiply both sides by 2. And then we would add 70 to both sides, giving us 130. Last one, half the sum or half the difference? Half the difference. Now x goes from edge to edge around there, but we need to know what the other one is. How do I know how big the other arc is? How do I know how big the other arc is?
Figure out who it is. At least that's 50.
There's a long runway. Yeah.
How do I know how big the other arc is?
You set up an equation. You do
58 times 2.
Well, we're going to have 58 is equal to half the difference of the two arcs. X is going to be the smaller arc because it's the closer one. How big is that other arc? $360 minus x. You got it. A whole circle is supposed to be 360. So x is using up a portion. The rest of it would be the rest of the 360, or 360 minus x. Like in the last ones, we're going to multiply both sides by 2. So that gives us 116 is equal to 360 minus 2x. The negative x and negative x gives us negative 2x. Subtract that 360 from both sides. 116 minus 360 is negative 244. And divide that out by the negative 2. And we get x is 122. Inside angle, half the sum. Outside angle, half the difference. If you're solving for one of the arcs, you will need to set up an equation to solve. Questions on any of these problems? Your homework is from 9.6, and I have a suggestion for you on questions 1 through 10. Questions 1 through 10 are all in one. I would suggest that you redraw that diagram, just trace it onto your homework paper, and label things as you find them, and do not feel like you need to find them in order. It might be easier to find number 6 before you find number 3. I don't know, I'm not looking at the picture. But don't feel like you have to answer number 1 first, and then number 2, and then number 3. Find them as you go in the picture so that eventually you find everything. There's a lot of built-in review in 1 through 10. So look for inscribed angles. Look for central angles. Okay? It is not just new stuff in problems 1 through 10 there. We are on lesson 6 of 7. We have one more lesson to learn. I've said several times now, this test can be a rough one because, as you have seen so far, we have a lot of terms, we have a lot of theorems and rules. So reviewing and practicing old stuff as we go along will help you. So don't save it all until the night before to study and review, but review and practice old stuff as we go